Hey, welcome back to RamZland. Today I want to show you an easy way to detect the presence of carbonic acid by using the indicator phenolphthalein. Check this out. All I'm using in this investigation is acetic acid, that's commonly called vinegar, sodium bicarbonate, we call that baking soda. I'm going to use the indicator phenolphthalein. Two 250 milliliter flasks. I'm going to fill one with vinegar and the other with distilled water, a pair of tongs, and this glass pipette. The first step is to heat up my pipette so I can curve it so it leads from one flask to the other. I'm just rotating the pipette until it gets warm enough for me to bend. Almost there. You see that orange flame? That's caused from the sodium that's in the glass. I'm able to start bending it. Okay. That's about where I want it. Now I'm going to close the valve on the bottom so that it uses oxygen above the burner for combustion. That's a much cooler flame, and I'm going to use that to anneal the part that I bent. That allows the molecules in the glass to shift back to a more comfortable location so that when the glass cools, it doesn't crack. Okay, once your glass is annealed, you're ready to make another bend in this part over here, and this is to lead down into that second flask. So I'm going to start heating it up over here now, because we want to bend it one more time. There we go. And that looks just right. I'm going to close the valve so that it combusts with oxygen above the burner for annealing. Cool down that bend. So my glass doesn't crack. That looks just right. Okay, so here's the glass apparatus that we just created. Add about 100 milliliters of acetic acid vinegar to your first flask and add a couple drops of phenolphthalein as an indicator to the next flask. We know the phenolphthalein turns pink in the presence of a base, and it turns clear in the presence of anything that's acidic or pH neutral. So right now it's clear. So to turn my phenolphthalein to pink, I'm going to add a few drops of ammonium hydroxide, which is a strong base. And right away, you can see that phenolphthalein turn pink in the presence of a base. Now what I want to try is adding sodium bicarbonate to our acetic acid to release carbon dioxide. We're going to run that carbon dioxide back into the second flask and see if we can turn that phenolphthalein from that pink color that indicates the presence of a base, something that's alkaline, back to a clear color that shows us that there's an acid that's present. Is specifically carbonic acid. Okay, so here's the moment of truth. I'm going to add 1 spoonful of sodium bicarbonate to my acetic acid, my vinegar, in this flask. That's a double displacement reaction at first, where it forms carbonic acid and sodium acetate. But that carbonic acid is so unstable that it immediately decomposes into carbon dioxide gas. We want to lead that gas with the apparatus that we made into a flask that has phenolphthalein. Right now it's pink, but if there's enough carbonic acid that forms in this solution, it'll turn clear again. That's what we want to find out. So here we go. I see bubbles. It looks like my solution is turning clear. All that carbon dioxide is turning into carbonic acid when it combines with the water in this flask, and the phenolphthalein turns clear to indicate the presence of an acid. Check it out. So let's take a look at the chemical equation for this reaction. It begins as a double displacement reaction with acetic acid or vinegar and baking soda, which we call sodium bicarbonate. Those are our reactants. The NaHCO3, that's baking soda. The HC2H3O2, that's vinegar. And those reactants, when they combine, they create the products sodium acetate and carbonic acid. Now the carbonic acid is unstable, so it begins to decompose into water and carbon dioxide gas. Well, I hope you enjoyed today's edition of RamZland, and I'll see you next time.